And good morning, space weather enthusiasts. We've got spectacular solar imagery as always. We've got a significant decline in solar activity here, lowest radio flux since the month of May. Lots of solar filaments, and plenty more to cover, like the Mars rover detecting a sunspot on the far side of the sun. We'll talk about it here at the Smash News Network, least busted name. In news, this is the past 24 hours from SDO. 304 angstroms depicts the extreme ultraviolet emissions of very, very hot 90,000 degree Fahrenheit ionized helium. And again, the story is filaments. So here's a quick view of the northern hemisphere, and you'll see a bunch of filamentary features there. For example, there's one to the left of the Earth scale. There's one becoming a prominence down in the, what's the lower right image there, the northwestern limb. Filaments, filaments, filaments remain the main feature here. So here's the eastern limb, and indeed, several more active regions appear to be rising there. We see huge plasma loops behind the eastern limb. At least their anchor points are behind the eastern limb. Also a massive filament there right near the Earth scale, basically in between those two sunspots. And the most active region has been this region right here. The largest flare of the past 24 hours occurred while we produced this show. Seems to be kind of a common feature. We've been seeing it go on repeatedly. The most action as far as coronal mass ejections and so forth have come from the western limb. That setting sunspot up there in the northwest has been the source of more than one coronal mass ejection, I'll just say. And here's a little closer view of that. You want to see that even closer? All right, there we go. There's the full zoom. And those areas that are white feature a lot of ionized helium. The areas that are dark feature low quantities of ionized helium. Anyway, before we take a look at sunspots and so forth, let's take a look at a story. So we had a number of comments about this story, and it does have a great graphic depicting ejecting solar plasma and a great Cartesian grid-like coordinate system there, and a wave of magnetic energy or something is being depicted there. And again, a number of comments here, and even on Twitter, about this story right here, which has an ultra clickbait headline, which not really a fan of that. Giant sunspot seen by Mars Perseverance rover may soon disrupt Earth's power grids. So let me just sort of nip that in the bud right away, folks. Sunspots do not disrupt Earth's power grids. Sometimes sunspots are the location from which we see a coronal mass ejection erupt from, but the sunspots themselves do not disrupt power grids. So let's just dispel that right away. Sometimes coronal mass ejections occur in the region where sunspots are seen, but the sunspots themselves do not disrupt power grids. So this is just a clickbaity article here, and you know, I'll let it scroll if you'd like to read the article. This one is from earth.com. It was picked up by msm.com. It gives some perfunctory descriptions of different features of CMEs and so forth. And looking at sunspots here over the past, well, this is about a day and a half at this point. That is August 25th and August 26th to date. No major changes happening there. All of the sunspot groups on the Earth-facing portion of the solar disk have been quite stable. And, I mean, there you have it. Not a lot else to say besides that. declining solar activity here. Again, the lowest levels that we've seen, at least in terms of the radio flux, since mid-May of 2023. So here's the colorized magnetogram for the same period, yesterday and today to date. So that's what's going on in terms of sunspot activity, and let's take a look at volcanic activity. By the way, that is ash and lapilli scoria from the Shishaldin volcano, which, let's see here. It entered a strong eruptive phase that produced a 40,000-foot plume of volcanic ash there. That has now simmered down to about a 28,000-foot plume of volcanic ash. Please do not pole vault Shishaldin. It could be unhealthful. Flight level 280 over the Alaskan volcano. Cleveland. Some seismic activity decreased there, and the volcano alert level lowered to green at the Cleveland volcano, also in the Aleutian Islands. Popocatépetl, no recent volcanic ash observed in central Mexico. Fuego in Guatemala, however, exploding flight level 150. It's a 15,000-foot ash plume, 19,000-foot ash plume from Nevado de Ruiz in Colombia. Sangay in Ecuador exploding, flight level 200. It's a 20,000-foot ash plume. New volcanic emissions from Revenador, also no indication on the plume size. Sabancaya exploding in Peru, also Ubinas, both producing 24,000-foot ash plumes, both exploding, flight level 240 over both of the Peruvian volcanoes. And let's move on to seismic activity. So there are the past 90 days, and we are indeed in a 7-magnitude earthquake drought. So a little bit overdue for a 7-magnitude earthquake. We're going to call out earthquakes above a 5 magnitude. We're going to cite one that's a pretty uncommon occurrence here. Here's a 4.0 magnitude on the New Mexico-Colorado border there, in the high mountains of the, I don't know what mountain range that is, but the peaks there are around 9,000 feet near Lawrencito Canyon. So a 4.0 magnitude quake happening there. That one occurred at 8:38 Universal Time just this morning. So anyway, again, we'll cite quakes of a 5 magnitude or greater around the world. And a quick reminder that any earthquake can be a foreshock. So you can see a large earthquake and have a larger one in the same place. That is one of the statistical realities of earthquakes. So starting out the list, here's a 5.2 at the Sandwich Islands. That was at 1722 yesterday afternoon. So this is a global uptick here. Quite a few more earthquakes than we reported the last few days. Philippines had a 5.0 at 1913 Universal Time yesterday evening. And then 1 minute later, Papua New Guinea. So 2 quakes there almost simultaneously. A 5.0 at Philippines, and 1 minute later a 5.1 at Papua New Guinea. You have to wait over an hour to see the next 5 magnitude quake. It was a 5.3 in the southern Mid-Atlantic Ridge. That was at 2047 Universal Time yesterday evening. And then things calmed down until once again, while we did the show production here, a 5.0 at West Macquarie Island, south of Australia there. That 5.0 occurring at 9:40 Universal Time. 62 minutes after this 4.0 at the Colorado-New Mexico border. And getting back to space here, the 10.7 centimeter radio flux now down to 139 solar flux units. So again, lowest levels that we've seen here. We'll get to that in a moment. First, let's take a look at some more solar imagery here from our custom Helio viewer videos. There is the past 24 hours in SDO 171 angstroms, the house favorite. I would make note of those large plasma looping filaments that are rising up over the eastern limb there. They do suggest that there is at least another sunspot or two likely to rise soon in the next couple of days in the east. We've also added 211 angstroms to this. Let's get back to our space weather stats here. the 10.7 centimeter radio flux. So if you're not familiar with what this is a radio emission that comes out of the upper chromosphere and lower corona. So right around this area here. And it is directly proportional to sunspot number. In other words, a high radio flux means a high sunspot number and vice versa. They are historically extremely tightly correlated. And there's the 1 year graph again. Lowest levels we've seen here since mid-May of this year. Radio flux at 139 solar flux units. Solar flux units are 10,000 Jansky, which is a measurement of radiation traveling through the near vacuum of space. So that's the situation for solar activity there. Sunspot number all the way down here to the high 70s. So lowest sunspot number since, well, just a couple of weeks ago here. So Space Weather Enthusiast dashboard is not forecasting any sort of geomagnetic storms or geomagnetic unrest, and we don't see anything likely to happen either. So it looks like NOAA, NASA, and I all agree on this one. No space weather is imminent at the moment. And let's move on to take a look at Earth's magnetic moment from space over the past 4 hours. A lot of people are very worried about the pole flipping. And if it were, we'd see all kinds of weirdness happening on the space weather modeling framework. Things are looking pretty normal here. It is geomagnetically calm. Here's our magnetic moment from the ground for planet Earth. We have seen a slight strengthening of the magnetic field, so that accounts for some of this increased magnetic flux density on the surface level. That depicts the last 4 hours. It's our ground magnetic perturbations map. Geospace delta B changes to Earth's B field. The B field being the field that goes through the magnet. Speaking of magnets, Earth's geomagnetism is currently at 2.67. KP 2.67 is the planetary K index. And let's look at the real-time solar wind next, which is quite nominal here. Just over 400 protons, 400 kilometers per second for the solar wind speed. 406 kilometers per second. Solar wind density here very diffuse, only 1 proton per cubic centimeter. And again, there was a minor strengthening of the magnetic field, also a shift into the negative BZ there. So we had an 8 nanotesla field. At the moment, we've got a 7 nanotesla field with a BZ of -3. So that creates a little bit more induction into the Earth system. And that will be accounting for those small little upticks that we see in likelihood of aurora visibility and so on. GOES magnetometers here. Seeing a little bit of a perturbation happening there. Again, that is likely associated with that shift in the magnetic field strength and orientation. Next, we'll view the top view ecliptic plane field plot. And as you may have come to expect if you're a regular viewer of the channel, Earth is now solidly in a North Pole current sheet. So there's the North Pole current sheet depicted in green, having left the South Pole current sheet sometime after yesterday's daily space weather video. And we can expect the North Pole current sheet to persist here for a few days, assuming nothing rapidly changes, which can happen with the magnetic plasma environment. Here's our line of sight field plot. Here the sun's B field is depicted in blue. Polar fields in red for south and green for north. And let's move to coronal holes. What evil lurks in the depth of coronal holes? The Smash Team knows. Especially Gold Smash Team members. Gold Smash Team members are on the absolute cutting edge of heliophysics. Especially if they read my crap theory about the solar cycles. I guess it's only a crap hypothesis at the moment. It's got to pass peer review first. Then it'll become a crap theory. CRAPF, what does it stand for? It'll cost you $9.99. All right, so here's the latest image. And we've got North Pole-oriented coronal holes here dominating the Earth-facing portion of the solar disk. The only South Pole coronal holes are located up here in the northwest, rather. So these are south. All the rest of these are north. That's another 24-hour video, SDO 211 angstroms. And you can expect this uptick in coronal hole activity to continue, because, frankly, we've seen a shortage of coronal holes for the past 3 years. Solar Cycle 25, at least the beginning portion of it, has featured a low number of coronal holes. So, not a lot of geomagnetic effects from coronal holes. That will not continue. That will tick up sometime in the next 2 years. So sometime before or just after solar maximum, expect to see lots more coronal holes. So, it's a very important thing to understand, folks, that the troughs are as important as the peaks. So not all data sets are right side up. So you have to examine the troughs and the peaks. It's not only the peaks that matter, the troughs are absolutely relevant as well. And indeed, we're in a trough right now, a trough of solar activity where it's quite low, despite only being about a year out from solar maximum. So it won't continue. And there are several different data sets that back up this theory. Solar maximum, we're not there yet. People have been saying we're there since January of this year, and I don't know what they're looking at. They are in a world besides reality. So anyway, the largest flare of the past 24 did come from sunspot 3413. Let's move on to energetic particles. We're going to show you high-res imagery of the solar intensitygram and solar magnetogram here before the end of the video. So solar energetic particles are next. The GOES proton flux here is flatlined. So for some reason, the GOES 18 is now off of this measurement. It's only showing the GOES 16 for the past month or two. Not sure what's going on with that, but I'm not too concerned about it. And here's the largest flare of the past 24 hours, again occurring right as we did show prep. It was a C2.26 approximately. Peak flux was right around 10 o'clock universal time this morning. Here's a 3-day chart, which is what we usually show. All right, I stand corrected. This flare was larger. That flare was larger. That was a C4 practically. A C4 class solar flare. And let's take a look at some more SDO videos. So here we've added 131 and 171 angstroms, 2 different species of ionized iron from SDO. And I think that C4 flare came from this active region up here in the northwest. Here we've subtracted 171 angstroms. This is just 131 angstroms by itself. And now we've switched to 94 angstroms. And while that's up there, let me just talk for a brief moment about these images being fake. We get regular comments about these images being fake. I think this is like on the scale of flat Earth, and it's just ridiculous. So the reason that the SDO is in space is because the extreme ultraviolet light portion of the electromagnetic spectrum doesn't make it down to the ground. You've got to be above the mesosphere, up in the ionosphere or higher, in order to see these wavelengths. So yes, it's CGI, because these wavelengths aren't visible to the naked eye in the first place. So, I mean, I guess you could say it's CGI. All digital imagery is CGI. Have you ever noticed how your digital camera can take images of infrared light, like from a television remote, and how it can take images of ultraviolet light, which is the primary spectra of the Earth's aurora? Well, you can't see extreme ultraviolet light from the ground. However, most of these features that are going on here are visible from the ground, using a $200 solar filtered telescope. I mean, the sun is about the size of the full moon, so it doesn't require a lot of zoom or an expensive telescope to see all of these features. So yeah, just covering the, oh, this imagery is fake nonsense that we see at least a couple of times a week on the channel comments. I don't know what's up with it. They think we're drawing in this information or something. It's showing a very specific portion of the extreme ultraviolet spectra. So, you know, the electromagnetic spectrum, it consists of radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. The electromagnetic spectrum, this is one extremely thin band, 94 angstroms. The emissions of extremely hot iron gas. Anyway, moving right along, let's take a moment to look up, shall we? So here's our star chart. This is what's going on overhead Lehigh Valley, Pennsylvania. Venus has become viewable in the morning. So if you're up before dawn, you can get a great view of Venus. Did you know that Venus can stop a train? Yeah, Venus has stopped a train already. Doesn't that seem crazy? Jupiter is up there high on the ecliptic, and you can also see the brightest intrinsic object visible from our entire solar system. There it is, Deneb, a blue supergiant Wolf-Rayet star being orbited by an even more massive compact companion known as its, quote, little friend, Cygnus X3, one of the weirdest objects in the whole galaxy. The brightest intrinsically bright object that is visible from the entire solar system, Deneb. One of those jets from X3 is pointed directly at your face. And let's talk about classifying galaxies. So if you've never seen it before, Galaxy Zoo requires humans to classify galaxies. So if you want to get involved in citizen science, zooniverse.org is a place. And let's classify a galaxy just to demonstrate what it's all about. So this one has features or disk. It looks like an edge-on disk to me. Does it have a bulge at its center? Well, it certainly does. It has a rounded bulge. Are there any bright clumps? Well, it looks like there are some bright clumps, so let's mention that. I don't see any disturbance there. It looks like it's probably just a spiral galaxy at a great distance. And do we see any of these features? So let's see. I'm not going to say that I see a ring. It is slightly irregular looking. There is a dust lane. There may be some overlap. And we do see central diffraction spikes. So there you go. There's a galaxy classified. And there's the next galaxy we could classify here at Galaxy Zoo, zooniverse.org, Citizen Science Project. AI is incapable of doing it. Is it because it's asinine imbecile? I don't know. Let's do a solar system forecast. This is where things are today. There's where things will be in a week on September 2nd. As we get closer and closer to the autumnal equinox, or the vernal equinox if you're in the southern hemisphere. And let's talk about Sagittarius A star. So, you know, when I was in third grade, I was kind of spooked about Sagittarius A star. I thought, man, it's kind of crazy that the sun orbits the center of the galaxy. And back then in the 1980s, the word black hole was kind of a bit of a controversial term to use. Now it's a very common term to use. By the mid-90s, we referred to black holes as massive radio sources. It is a term I still prefer. I won't get into the controversy about black holes and about cosmology in general, but the point is, Sagittarius A star is not going to kill you. It is not interacting with our solar system. It's about 26,000 light years away. But it is certainly a massive radio source. There are huge blue supergiant stars that orbit it. And of course, there are giant jets that come out of galactic cores typically. Sagittarius A star is no outlier when it comes to galactic jets. The Milky Way galaxy certainly has those. It's about 4 million times the mass of the sun. And that's a pretty accurate calculation because we're calculating stars that are orbiting it at incredibly high rates of speed. Here's a great image of it that is from some radio telescope. The Event Horizon telescope, of course. And yeah, Sagittarius A star, the core of the Milky Way galaxy. If you want to follow its X-ray emissions, you can do that on a daily basis if you like. And here's how. Head to the Neil Gorell Swift Observatory, the Swift-BAT Hard X-ray Transient Monitor. That stands for Burst Alert Telescope, by the way. Neil Gorell was interested in the most energetic events in the universe. And so this X-ray observatory is named in his honor. If you want to look for Sagittarius A star on it, just type in SGR space A, and you'll get to entry number 709. There are the hard X-rays from the core of the Milky Way galaxy. And we have seen a greater variation in it. However, most of it is a very low level of an X-ray flux as measured from Earth. There is a lot of dust in between Sagittarius A star and Earth, so we don't get a very good view of it, especially in wavelengths besides radio and infrared. So that's what it looks like in X-rays. You can see it's kind of all over the place, occasional little bursts from it. It's not really interacting with the solar system. It's just kind of hanging out there. And again, I was a little spooked of Sagittarius A star when I was in about 3rd grade. However, astronomers even back then were not very concerned about the massive radio source at the core of our galaxy doing anything to us because, well, it's too far away. There's too much stuff in between us and it, and galaxies don't work that way. Galaxies are nothing like solar systems. They're extremely complicated, and things are extremely far apart from each other. So if you're spooked of the galaxy causing some sort of destruction on planet Earth, you should just unspook yourself because it's not spooky. It takes about 250 million years for the sun to complete one orbit around the galactic core, and the gravitational interactions are extremely weak. There's not a lot going on there. Now let's talk about the train stopper. Yeah, there it is, the train stopper. Now Venus phases because it's in between Earth and Sun, and so around the 13th of August was the conjunction of between Earth and Venus there. And so anyway, so you get a crescent Venus. Only a portion of it is lit. So while it gets quite bright in those moments, because it's close, it also is only partially illuminated. Venus is the 3rd brightest object in the sky, bar none. And the way it stopped trains is because there's at least one case of a conductor, and around like what's going on now, Venus rising in the morning, this conductor thought there was a train coming in the opposite direction, and so they did an emergency stoppage, only later to realize that what they were seeing was Earth's twin, the 3rd brightest object in the sky, Venus, which is the astronomy picture of the day, by the way. apod.nasa.gov. And let's move on to coronal mass ejections. They've still been minimal here, and we don't see any earthly directed ones that I'm aware of. Based on the information I see, we ain't got no space weather on the way. Things are chill in between Earth and Sun. That's 95 frames from yesterday. Here are the 38 frames available from today at George Mason University. And good news about Stereo A is coming. Yeah, Stereo A. The regular coronagraph is back, baby. We're going to show it. First, a brief look at LASCO C2 and C3. By the way, they're located at Lagrange Point 1, the same place ACE and Discover are measuring the solar wind. And let's talk Stereo A. So Stereo A had some issues, and it looks like those have now been resolved within the past 24 hours, so that's great news. And we just like to show this because it shows the location of Stereo A now finally moving to the west of Earth. It'll provide better and better trajectory information about coronal mass ejections. So here we've paused this one. This is Stereo A's regular coronagraph, and this is what it looked like 2 days ago. Yowzers! That is because its antenna needs to be directed toward Earth, and that messes up the coronagraph. So that was unfortunate. However, the difference imagery was still working, so That's what we've been showing. And you can see indeed some CMEs there out of the western portion of the sun, the northwest and just the due west. Those do not appear to be earthly directed coronal mass ejections. Next, Soho Lasco C2 and C3. And you should see a similar CME profile here. But don't fret, folks. Don't fret, because things are going to tick up. You can bet your bottom dollar on that. Why? Because filaments. Filaments. Check out the Lermonth, Australia ground-based hydrogen alpha telescope. Look at all the filaments, especially on the eastern limb. I mean, let's just briefly count here. So we're going to count this as 1. This is 2, 3, 4, 5, and that's a big one. 6, that's a big one. 7, 8, 9, no less than 9 filaments. And that's not even counting these ones that are setting. So 10, 11, 12, at least a dozen filaments, significant ones, on the Earth-facing portion of the solar disk. By the way, if you'd like to name those, make sure you follow the hashtag NameThatFilament on Twitter. We'll talk more about that in a minute. First, let's show the grayscale imagery, since this shows prominences. So you can see quite a few prominences here hanging off the edge of the solar disk. Those are just the same feature as filaments. They're just, when they're hanging off the edge of the solar disk, they're called prominences. It's not really anything different. The plasma on the sun is very bumpy. So like this thing here, these are three-dimensional features viewed on a two-dimensional plane. So it's there's a lot of plasma pointed at the Earth right now, and there's about to be more. So CMEs are expected to uptick in the coming days. And let's talk once again about naming filaments. So if you are on social media and you aren't following us on Twitter, you ought to be, as we share stuff on there that nobody else gets to see. Once again, if you want to follow the hashtag NameThatFilament, we're naming filaments after living people. Because filaments, like living people, most living people, are kind of lively. So follow the hashtag NameThatFilament. And you can name filaments also after your friends, your foes, or perhaps even yourself. Interesting fact about Twitter is that a lot of fanboys and a lot of people who are just susceptible to utter nonsense seem to think that censorship has been fixed, or that Twitter is some sort of a free speech platform. It couldn't be farther from the truth. How is it a free speech platform when censorship continues on the platform? What? And why are people paying for blue check marks while knowing that their content is censored? It makes no sense. So this idea that somehow Twitter has restored free speech to the internet is just complete shite. I mean, what are you talking about? How is free speech restored if censorship continues on the platform? I mean, what? Folks, the amount of nonsense that is currently believed has got to be at an all-time high. I mean, I think more people believe the Earth is flat now than did 2,000 years ago. Think about how insane that is. Yeah, it's ridiculous. Anyway, our Twitter feed it's been in existence since 2019, the same year that we launched smashomash.com. It's got over 21,000 tweets, daily original content, our own web ring, daily interactions, and not even 500 followers on Twitter? Are you kidding me? Oh, yeah. Thanks for fixing censorship on the internet, Twitter. You're doing a fine job of that. So here is the last couple of hours. It looks like we may have a coronal mass ejection occurring here, so check it out. this sunspot here, which is the one that I've been stating was my favorite to produce a large flare. Looks like it may be producing a CME here. So we'll zoom out to show the time and date stamps there from the GOES 16 SUVI. And just let that play out. It could be a filamentary collapse or a reorientation, or it could be a coronal mass ejection. Fingers crossed for the third. It's almost right in the Earth-facing portion of the solar disk. So let's get some space weather going. And yeah, hopefully it's earthly directed. And if you're frightened of earthly directed coronal mass ejections, I don't know why. They're mostly harmless. And yeah, there you go. The past couple of hours, and let's move to bonus features. We don't want the video to be too lengthy. First bonus feature is charging hazards for satellites. We've only got minor surface charging hazards here at the moment over the eastern Pacific Ocean and Mexico. That's caused by low-energy electrons, which have a tendency to build up on the outside of spacecraft. The GOES electron flux, which is a measurement of the F layer of the ionosphere, kind of low here. So we saw a little dip in electron flux. Not expecting any major changes to that because there are no major space weather events likely. There's the one-year graph to put the electron flux in context. That is from solon.info if you want to follow that yourself. And here's the forecast model, expecting a dip here. So perhaps NOAA is expecting a coronal hole high-speed stream. If so, they're not expecting it to be very geo-effective because NOAA's not forecasting any geomagnetic storms or geomagnetic unrest conditions. So that looks like a coronal hole high-speed stream impact. And hopefully we do see one. Keep in mind those impacts' intensity is based on the magnetic field strength and orientation, also the density and speed of those coronal hole high-speed streams. Next, the visualization of the F layer in vibrational frequency from Australian Government Bureau of Meteorology. And by the way, this is what I was talking about earlier. Extreme ultraviolet. These are the wavelengths that we view from the SDO, like 94 angstroms. And if you look at this little visualization here, you've got to be above the mesosphere, because by the time that you get to the bottom of the thermosphere, the extreme ultraviolet light is adsorbed. That is why we need to use things like the SOHO at Lagrange 1, the SDO, or the GOES satellites to view things like 171, 94, 193, 304 angstroms, because those wavelengths don't make it to the ground level. Anyway, here is the vibrational frequency. In megahertz, the F layer of the ionosphere, the bridge between Earth and space, courtesy of Australian Government Bureau of Meteorology, and things are looking quite normal. Sorry, folks, no disasters are being forecast by this ionosphere animation. You'll be just fine. Our finest days lie ahead. Here's the anomalogram depicting anomaly in megahertz from a 30-day median. Our finest days lie ahead. Civilization is not ending. The planet's not being destroyed. The solar system's not being destroyed. The sun's not going to explode. The sun, it's very unlikely to kill you. If there's anything to be afraid of bad decisions by humans, not of nature. Here is the latest image of the ionosphere, 11 o'clock universal time ionogram and 11 o'clock universal time anomalygram. We also show total electron content. It's useful for humans because it'll show you the most likely places to see GPS errors. Those free electrons can cause signal refraction like this. And yeah. So, however, they also show us information about what's going on in Earth's magnetosphere and so forth. So we show this for two reasons. One, it'll show you where GPS errors are likely. So that has a direct effect on our viewers. But from a space weather perspective, it also shows us if there's anything really weird and spooky happening in Earth's magnetosphere. And there's not, because if there were, we would see weird evidence of little Van Allen belts all over the place. But we don't, because we don't think a pole flip is occurring. The little pole shift that's happening isn't spooky at all. It's not even a major geomagnetic excursion according to the geologic record. And where's all the spooky data, folks? It's just not there. It's a bunch of utter nonsense by grifters, scammers, and doomsday cultists. Things look totally normal. I mean, there's a little bit of electron out of place there in the southern hemisphere, but besides that, if you are spooked with a coupled thermosphere, ionosphere, plasmasphere electrodynamics model that we're showing here, you shouldn't be. I'll just say that. That's the most equitable thing I could say. We also like to show the total electron content anomaly for North America. We are seeing some high electron counts here over places like, let's see, Mexico, the west coast of the U.S., but they are minor. High electron counts shown here in red, low electron content anomalies in blue. It's anomaly from the 10-day average. We'll close out the space weather section of this video with the latest from SDO. And again, things are quite stable here. I still say this is the most likely place to see a large solar flare. It is certainly beta gamma class. Is it beta gamma delta class? Barely. This sunspot down here, that one is beta gamma class. I don't think that's beta gamma delta class. Anyway, here's your rock back. And let's move to meteorology, because we've got a little update for you here with respect to these tropical systems that are forming in the western Atlantic. So first of all, dust. Yeah, Saharan dust. Not likely to play a major role in this system, which is expected to kind of move up toward Bermuda. So Bermuda is in the crosshairs of that. And it looks like all of this dust over here is going to largely leave this thing unfettered. So there's also a low forming here right around the eastern tip of the Yucatan Peninsula. That will affect the Gulf states here in a few days. And we'll show you some forecasts on that here in a moment. First, and one other thing, sea surface temperatures. So this is another way to get some indication of what is likely to happen and not happen. Sea surface temperatures. So this low forming off the Yucatan has a lot of very warm water to its north. So that will aid in convection. It will likely strengthen this low. This low here, this one right here, this one has some decently warm water as well. So also not a lot of wind shear affecting that. If you look at the upper level winds here, they are pretty chill. So speaking of upper level winds, let's go around the planet. Shout out to our viewers from Fromunda. There are the jet streams of the eastern world. And here are the surface winds of this side of the planet. There's a typhoon off the coast of the Philippines. Here are the surface winds of the central world. Shout out to our viewers from this side of the map. Don't forget to press the share button. Do yourself a favor and press like. Actually, do us a favor and press like. Do yourself a favor and press subscribe if you are new to the channel. Here are the jet streams of the central world, blowing backward over the northern Indian Ocean and northeastern Africa. Pretty chaotic jet streams there over Europe. Next, jet streams over the U.S. and South America. We've got a huge anticyclone here over South America. Check it out. We've got this counterclockwise rotation indicating a high pressure zone, an upper level high there over the, that's the East Pacific as well as the northern portion of South America. Last but not least, here are the surface winds of the west the Americas, etc. And let's do a forecast. So this is a windy.com mean sea level pressure map. And the pressure isn't so low yet, but this is going to strengthen as it moves up to the north. So all indications are for that. Let's move this ahead. We're going to actually move it ahead 2 days. So there's where that's expected to be Monday, as this low strengthens down here off the coast of Yucatan. The pressure is expected to drop on this. But in 2 days, not so much. By 3 days, it will be a bit stronger. So it's going to strengthen. It's going to move to the north in that period of time, and any forecasts beyond that are a little bit too far out. By then, this low in the Gulf will be north of Cuba. That's the Euro model. Here's the GFS model. It does have this low weaker in the Gulf and farther to the west, and it has this closer to Bermuda. So again, there's the Euro model for about 3 days, and there's the GFS model for about 3 days. And let's move on to look at clouds and fog over this side of the planet. There you go. That's a shortwave radiation map depicting clouds and fog, even though most of that map is still dark. Next, our smoke map. We've got some extremely intense fires there in northern Canada there. Dag. Some majorly thick smoke. Let's zoom in one step here. That is the smoke forecast. Firesmoke.ca if you want to monitor it yourself. And here's our weather.gov map. We do have some heat warnings for the most part. There's the key to briefly show you that. Weather.gov, the homepage of the National Weather Service. And here comes some forecasts. So first is a 72-hour GFS pressure and precipitation forecast. Expecting that low to drop all the way down to 956 millibars there. So that is a significant uptick in that tropical system. It's going to be quite close to hurricane winds at that point in time. 956 millibars is a significant tropical low. Here's the GFS temperature anomaly forecast in degrees Celsius for the same period, 72 hours. Last but not least, the jet stream forecast, as this can certainly affect things. So that system will run into some wind shear here if it keeps moving to the north like that. And also the water will get cooler, so the propensity for additional convection will be dropping. And the propensity for wind shear to tear apart the upper level portions of those clouds will be rising. So there you go. 72-hour jet stream forecast featuring the 250 millibar winds. By the way, if you enjoy the content, make sure you press like, subscribe, and share. Leave a comment. And if you're mad about facts, then tell us all about how mad you are about the facts. We do read all comments, even the silliest ones. Here's lightning over the past 10 hours, and the most extreme lightning was in places like Illinois and southern Indiana. That's about 10 hours of lightning, and let's check our real-time lightning map to see what's going on. We've only got some minor lightning strikes in the U.S. as the sun rises over the Mississippi Valley. Here's the full globe map. Lightning pretty chill here at the moment on a global scale. Now, if you want additional content because you like what you see on these videos, then consider becoming a member of the Smash Team. As, again, like on Twitter, we put out information on the Smash Team site that nobody else gets to see. The biggest set of information is for Gold Smash Team members, obviously. There's also a silver level. There's even a bronze level, which costs $0 per month. We send out email alerts for videos just like this one. If you're mad about not getting notifications about our daily space weather content, then sign up for email alerts. It seems like a simple solution. Most of our viewers have not have not utilized this solution, getting email alerts about our videos directly in your inbox seems like a logical thing to do. If you want to support the channel financially, one of the ways you can do that is via our Amazon shop. Yeah, we've got an Amazon storefront at amazon.com/shop/smashomash if you want to drink the same coffee we do, or get deals on bulk spices, or learn about the best insecticide to use, or perhaps the world's best flying discs. Smashomash.com has links to it. Amazon.com/shop/smashomash. Today's featured product is Do the Math. Because, well, folks, we talked about Sagittarius A star earlier, so let's make it a theme. Do the math. 8 == capital D. Now that features a high-res multi-wavelength image of the core of the Milky Way galaxy. Sagittarius A star, the massive radio source around which the rest of the galaxy largely orbits. If you're spooked of the galaxy, if you think the galaxy is anything like the solar system, we recommend that you do the math and not suck at it. 8 == capital D. We've shown our work. Hopefully you're not engaged in too much work. Again, 8 == capital D. Do you suck at math? Links to the Redbubble shop below this video as well as on the homepage at smashomash.com. Another paid affiliate is our Hemp Lucid shop, as we strive to keep this channel in existence. And one of the ways we do that is by having paid affiliates/sponsors. If you'd like to be an affiliate/sponsor of the channel, drop us a line, send an email. You can reach us in various different ways. We're pretty easy to get a hold of. One of the ways to support the channel is via our Hemp Lucid shop. So if you've never tried out the products, perhaps try out the stress mushroom gummies. I know a lot of people are under a lot of stress, like economic stress. I don't know why people are not focused more on the economy. You would think that they are, as there is a lot of economic illiteracy in the U.S. However, get some biological literacy, perhaps. Improve your whatever situation might be going wrong, whether it's stress, sleep, immune boost, inflammation. CBDs for your pets there. By the way, the cedarwood body balm smells fantastic. Links below the video to the Hemp Lucid shop, as well as on the homepage at smashomash.com. So keep these videos in existence by clicking our links. Welcome to the Neo-Renaissance. Congratulations on realizing the channel exists, and so on. We're almost at the end of our advertising here. Smashomash.com. We launched it back in 2019, and welcome to the Neo-Renaissance. Watch out, folks. Facts. They're very controversial, especially in the last 3.5 years. Ooh, watch out, folks. Facts. Oh, no's. They're very controversial. Again, press like and subscribe. Press the like. No, that's okay. We'll wait. Have you pressed like yet? We'd really like to close out the video here, so if you'd be so kind as to... Oh, you've already pressed like, then visit the links in the description. It's only the world's most comprehensive daily space weather and most detailed solar imagery. No big deal. Next, U.S. Doppler radar. There are ground-based systems that measure vertical motion in the air column. Quite a bit of precipitation in Alaska and around St. Louis. All right, multiple levels of zoom here now at radar.weather.gov. Some improvements have been made there. Radar.weather.gov. Shout out. Here is a space-based system showing shortwave radiation. Great view of that likely hurricane there. It already has an eye wall. Check it out. And here is the water vapor map. And you can see some low pressure there coalescing off the coast of the Yucatan Peninsula. Also, the anticyclone over the U.S. continues. You've got this relative high pressure zone here, and you've got still some clockwise rotation happening there as an upper level high continues to largely dominate the U.S. weather system. Anyway, here's the U.S. Doppler radar map once more. The lower 48 recap. Here is clouds and fog. And there is water vapor. By the way, fun fact, if your Doppler radar is unclear, if you understand how to read the water vapor map, it will deliver you from ignorance about what's going on with the weather. Hopefully you're able to forecast your weather. Hopefully you're able to forecast your space weather. We put them both together on the channel, on the regs. Thanks for tuning in, by the way. Thanks especially to the Smash Team. These videos were brought to you in part by the Smash Team at smashomash.com/Smash Team. In the meantime, I am out. And while I'm gone, may that solar wind be at your back.